All right, so this is going to be a video on our last theorem for this unit. And this theorem is called the triangle bisector theorem. And as you might suspect, there is a bisector involved. So if you guys remember what an angle bisector is, an angle bisector is a line that splits a triangle, or well, not a triangle, an angle into two equal parts, okay? So I'm going to draw my angle bisector here. So my angle bisector of angle C splits this angle C into two equal parts, okay? So you are only going to use this triangle bisector theorem when you have a bisector inside of a triangle. If you don't see that, then you're not going to worry about it. We're not going to use it, okay? So what this triangle bisector theorem tells us is that I have my bisector here. So when I split this, let's say I'm going to label my sides now. 4, 8, and we'll say 5, 10. Okay. So what this triangle bisector theorem tells us is that if we look at either side of the bisector, so we're going to only look at this side, the proportion here, so 4 over 8, has to be equal to the proportion on the other side. So 4 over 8 should equal 5 over 10. Okay, so to set this up, we're going to look at one side of the angle bisector, and then we'll look at the other. And the division between them, or the proportion between them, should be equal. Okay, so you can see that 4 is half of 8, which means on this other side, 5 should be half of 10, and it is. Okay? So that is how you are going to use this triangle bisector theorem. You're going to look at one side of the bisector. So if the bisector splits it here, you're going to look at one half of the triangle. Those two lengths over there should be proportional. And then we're going to look at the other side of the triangle. And those two lengths should be proportional, and they both of those things then should be equal. Okay? So we're going to look at a little example over here. We're going to work through a small little problem, and then I'm going to set you loose to do 3 other problems like this, just to make sure that you know exactly what you're doing. So what we want to do here, we want to look, so we have a triangle here, and we have a bisector. And I know it's a bisector because they tell me that this angle right there is equal to that angle right there. So it is bisecting that angle. So that means that we are in a situation where we want to use the triangle bisector theorem. Okay? So what we're going to do, our process, is to look only at one side of the triangle, one half of the triangle. So I'm going to block these things out because I'm only going to look at the right side of this triangle right now. Okay? I'm going to figure out 3 divided by 6. Okay? So I'm going to say 3 divided by 6. You guys should be able to see that that's 1/2. You might end up having numbers that aren't as easy to do that with. But what you should do is you should say, okay, I know my one side, I'm going to divide it by the other side down here. Okay? So I'm going to have 3 divided by 6. Now, our triangle bisector theorem tells us that division, this fraction right here, 3 divided by 6, should be equal to the fraction that we make from the other side, or from the other half. So I'm going to ignore the 3 and the 6. I'm only going to look at the x and the 12. Okay, I want to do it corresponding, so 3 is on top, x is on top, so I want to have x on top down here. 3 over 6 should be equal to x over 12. That is what our triangle bisector theorem tells us. Sorry for my terrible handwriting. So 3 over 6 equals x over 12. Now we can just do our cross multiplication that we're used to. Okay? So I'm going to multiply 3 times 12. That's going to give me 36. You can do these things on a calculator. That's perfectly fine. And I'm going to multiply my 6 and my x, which gives me 6x. Okay? To solve, I want to get x by itself, so I'm going to divide both sides by 6. And I should end up with 36 divided by 6 equals 6. And 6x divided by 6 equals x. So my missing side length over here was 6. And you guys probably would have been able to tell that right away without doing this, because you would see that 3 is half of 6. So whatever x is should be half of 12. Okay? For numbers that aren't as easy to do that with, you're going to follow this steps process. So to recap the triangle bisector theorem, it is saying that if we look at one side of the triangle, on one side of the bisector, the fraction that is created by the two sides over there should be equal to the fraction created by the other sides. Okay? So now you should take this, you should try and apply it to the 3 problems that are on the slides after this video, and work through that.